we are moving on to the simplification in number systems. Numbers can be huge, it can be complex. So what do we do to make it simple, to make it understandable? So we use different methods of simplification. So first rule we need to know for simplification is the BODMAS rule. So why is it called the BODMAS rule? Every single alphabet represent every single things, like B represents brackets of division, multiplication, addition and subtraction. And again we are classifying the brackets which have more importance. Basically the BODMAS explains to you which one should be considered more important when you get a lot of operations in the same question. Like we have a question here which is 44 by 11 into 4 minus 12 plus 4. So according to BODMAS rule, first comes the brackets. So we do whatever inside the bracket first. So we keep all the other things here. We do 4 by 11 into 4 minus 12 is minus 8 and plus 4. What do we do next? Division, it comes after brackets. So division, it's 44 by 11. So 44 by 11 is 4 into minus 8 plus 4. And again we have multiplication after division. So we go like 8 minus 8 into 4 is minus 32 plus 4. Then we have addition here, so we are adding these numbers and we get a result of minus 28. So BODMAS rule is the rule which explains to you how or in what order you have to calculate a sum or any operation on a number when it have more than one operation. So this is about BODMAS and it's actually mentioned here. See, we have different types of brackets. We have the circular brackets, we have the curly brackets and we have the square brackets. So if we have everything in a question, which one should we use first, which one should we calculate first? We first go for the circular brackets and then for the curly brackets and then for the square brackets. This is how we do the calculations. Now moving on. So we have things called simple fractions and decimal fractions. What are simple fractions? If both the numbers, that is 4 by 8, the numerator and the denominator of this number is a whole number, then this could be said as simple fractions. It's fractions in simplified form. This can actually be written as, we could take 4 as a common factor and it can be written as 1 by 4. Now this is the simplified version of this fraction. Now moving on to the decimal fraction. Any fraction, if I'm taking 6 by 10, 6 by 10 is 0.6. 78 by 100, which is 0.78. Any fraction having 10 or multiples of 10 in the denominator is called as decimal fractions. I think both of these concepts are pretty much clear. And now we are moving on to the comparison of simple fractions. So now we got to know what a simple fraction. Simple fractions are the fractions which have numerator and denominator as whole numbers. So how do we compare two simple fractions? This could be done in 4 ways here. First one is, here we have two fractions, 5 by 8 and 2 by 9. So let's see how to compare these fractions. So it's 5 by 8 and 2 by 9. So first method we have here is cross multiplication method. In cross multiplication method, we multiply both the numerator of the first fraction to the denominator of the second fraction and the denominator of this first fraction to the numerator of the second fraction, which goes like 5 into 9 is 45, 2 into 8 is 16, and then we multiply both the denominators, which is 8 into 9, which is equal to 72. So now we compare whether this or this is the highest number. Now we know that 45 is greater than 16. So in case 5 by 8 is greater than 2 by 9. This is how we compare two simple fractions using cross multiplication. Let's take another example. 1 by 2 and let's say 5 by 7. So using cross multiplication, we have 1 into 7 equals 7, 2 into 5 equals 10, and 7 into 2 equals 14. So we have 7 here and 10 here, so this is greater. I think it's pretty much clear now. Now let's move on. The second method is by changing fractions in decimal forms. So this is a very straightforward approach to do it. So 5 by 8, 5 divided by 8. What is 5 by 8? 0 8's a 0. We are adding a point here, we add a 0 here. So 6 8's are 48. Add a 2, 0, 8 2's is 16, 4 again a 0, 5 8's are 40, 0. So we get 5 by 8 as 0.625. Now let's find the decimal version of 2 by 9. So 2 divided by 9, 0 9's a 0, again 2 comes here, we add a point, 2, 2 9's are 18, again we get a 2, 0, 2, it goes on. So we have 2 by 9 as 0.2222, etc. So we have 0.625 and 0.222, which is greater here, 0.625. So again, we got to the fact that 5 by 8 is greater than 2 by 9. So let's see the next way we could do this. By equating denominators of the given fractions. So our given fractions earlier were 5 by 8 and 2 by 9. So here we have to make the denominator same for these both fractions. How do we do that? We check for common factors of this. So we could find that 8 and 9 doesn't have a common factor. So what are we going to do here? We'll multiply 8 9 times and 9 8 times. So if you're multiplying 5 by 8 by 9, multiplying the denominator and the numerator, we get 45 by 8 9's is 72. And if we're multiplying 2 by 9 8 times, we get 16 by 72. So what is the situation here? We have 45 by 72 and we have 16 by 72. So 45 by 72 is greater than 16 by 72, which means that 5 by 8 is greater than 2 by 9. Again, we got the same answer. Now let's move on to the last method, that is by equating numerators of the given factors. So again, we are taking 5 by 8 and 2 by 9. Instead of making the denominators same, we are trying to make the numerator same in here. So what is the common factor between 5 and 2? There is nothing, there is just 1. So we are multiplying 5 by 8. We are multiplying the numerator with 2. So we are also doing into the denominator. We get 10 by 16 and about 2 by 9. 2 by 9, we are multiplying it with numerator with 5 and the denominator with 5, we get 10 by 45. So 10 by 16 and 10 by 45. How are we going to compare a fraction with the same numerator but different denominator? It's very simple. The lowest denominator is the highest value. So 16 and 45, 16 is the lowest denominator, so it's the highest value. It again gives us that 5 by 8 is greater than 2 by 9. So these are the ways that we could compare the fractions, like two fractions, by using 4 different methods. Let's talk about Euclid's division lemma. So division algorithm, first of all, division algorithm is also known as Euclid's division lemma. So what does this say? This says that if, let's say, I have a dividend, divisor, quotient and remainder. So I am dividing A by B, right? Now what is A by B? I'm saying Q times B is A, and which leaves a remainder 0, right? So this is giving me a remainder 0. So this is giving me a remainder 0. So here what is the divisor, what is the quotient, and what is the dividend and the remainder? So dividend is actually this number. So A is the dividend, B is actually the divisor, right? Q is the quotient, and 0 here is the remainder. I could say now Q times B is equal to, let's say, Z, and the remainder is R. So R is the remainder. So what does all these mean? Let's say I'm dividing a number 16 by 5, right? Now 16 becomes the dividend, 5 becomes the divisor, and 3 5s are 15. We all know that 3 5s are 15. So 16 minus 15 is equal to 1, right? So 3 is the quotient and 1 is the remainder. But what does Euclid's division lemma say? Euclid's division lemma say, or division algorithm says, that A is equal to, divisor is B, quotient is Q plus R. So when we think about here, 16 is equal to B into quotient is equal to 5 into 3 plus the remainder, which is 1, which will give us 15 plus 1, which is equal to 16, right? Now this is Euclid's division lemma. Now let's see in the case of polynomials. Here P of x is equal to Q of x into G of x plus R of x. What does this mean? Let's say we have a polynomial P of x is equal to 4x cube plus 2x square plus 8. Now Q of x is another polynomial, right? Q of x is another polynomial which is 4x plus 1. Now how do we divide this in the first place? So when we are dividing this, we have 4x cube plus 2x square plus 8 as the dividend. So this is the dividend, and we have the divisor to be 4x plus 1. So P of x is the dividend and Q of x is the divisor, right? So how much times x is x cube? We know that x square times 4x plus 1. What is 4x plus 1 x square times? We have x into 4x is equal to 4x cube plus x into 1 is equal to x, right? No, this is 4x square, right? So x square into x is 4x cube, and x square into 1 is x square. So we subtract it, we will get 0 for this, and 2x square minus x square is x square plus 8. We have x square plus 8 here. Now we will add, what do we add here? We have 4x plus 1. So we need to multiply it with 8x, right? So x times 4x plus 1 is 4x square plus x, right? So x square and 4x square is minus 3x square, right? And we have 8 minus x. So minus 3x square plus 8 minus x, right? In the case of here, we could write that 4x cube plus 2x square plus 8 is equal to 4x plus 1 into minus 3x square plus 8 minus, no, 4x plus 1 into x square plus x plus minus 3x square plus 8 minus x. So that is about Euclid's division lemma in case of normal numbers, and then we have it for the polynomials. Let's move on to our next topic, which is the test of divisibility. Say we get a number, that we get a very random number. So how can we say that whether that number is divisible in a particular number? Like if we get a number like 452, how can we say whether it's divisible in 2 or is it divisible in 3 or 4 or anything? So this unit is actually to make it easier for you. So how would be a number be if it is divisible by 2? For example, I'm giving you a number like 4784. Is it divisible by 2? Of course it is, because we check the last number or the number in the unit place. And if this number is 2 or any multiple of 2, we could say that it is divisible by 2. Basically, we are checking whether the number is even, then we get the divisibility of 2. So, if we take a number like 319, is this divisible by 2? It is not. Why? Because if the last digit is not 2 or neither it is divisible by 2. Now we'll check the divisibility by 3. So 3 have a very interesting thing to look for. If I'm taking the same number 319, we add the digits in between. That is 9 plus 1 is 10, 10 plus 3 is 13. So 13, 3 plus 1 equals 4. Is 4 a multiple of 3, or it's not 3 or it's not the multiple of 3? So of course it's not divisible by 3. So we take another number. We take 42. Is it divisible by 3? We add the digits, that is 4 plus 2 is equal to 6, and 6 is 3 into 2, which means it's a multiple of 3, and which means that it is divisible by 3. Moving on, now we check the divisibility by 4. So we have a number 4728. Is this divisible by 4? And how would we check it? We check just the last two digits. So is 28 divisible by 4? Yes, it is. So let's check it. 4728 divided by 4. So 1 4s are 4, 4 0, 7, 1 4s are 4, 3 2, 8 4s are 32, 8, and 2 4s are 8. We see that this is divisible, but we don't have to do this long process to determine whether it's divisible by 4. We could just say that 28, the last two digit of this number, is divisible by 4. Let me get another example, which is 6800. So we have two zeros in the end. This also implies that it is divisible by 4. So divisibility by 4 is just that. Now we have 5. 5 is the easiest among everything. So have you noticed the multiplication table of 5? It's always 5, 10, 15, 20. So what do they have? Either the last number is 5 or it's 0. So any number which have the last digit as 5 or a multiple of 5, that number is divisible by 5. Like 375. We have 5 here, so it is divisible by 5. We have 7845. Again, divisible by 5. We have 980. Again, we have 0 here, so it's divisible by 5. So divisibility of 5 is just that. Now we move on to divisibility by 6. We know that 6 is the product of 2 and 3. So if a number is divisible by both 2 and 3, not just one, but both 2 and 3, we just get to know that it is divisible by 6. If I take a number as 231, it's divisible by 3. Let's check it. In case of 2, it goes like it's not divisible because it's an odd number, and in case of 3, it's 3 plus 1 4, 4 plus 2 6, which is divisible. But it doesn't matter because it's not divisible in 2. So let's check again. We have 42 again. So divisible in 2, yes, because it's an even number. Divisible in 3, yes, because 4 plus 2 is 6. So this is how we check the divisibility by 6. Now we are moving on to divisibility by 7. Divisibility by 7, it just says that subtract double the last digit of the given number from the remaining number, and if the remaining number is a multiple of 7, it is divisible by 7. So it sounds a little bit complicated. So let's see. We have a number 235. What we do to check the divisibility by 7 is we take the last digit, which is 5. What is double of 5? It's 10. We multiply 10 from 23, which is the remaining digit. We get 13. Is 13 divisible by 7? It is not. So it's not divisible. Let's move on to a bigger example. If the same question was like 2355, we could take this one, double it. 5 into 2 is 10. So subtract 10 from 235. We get 5, 2, and 2. We get 225. Now again, we are repeating the same process because we don't know whether 225 is divisible. So we go like 5 into 2 is again 10. So 22 minus 10, that is 12. Is it divisible by 7? It is not divisible by 7. So this is how we check the divisibility of a number by 7. Okay, now we check the divisibility of 8. In the divisibility of 8, if the last 3 numbers of a digit, that is if I'm saying 4,844, if last 3 digits of a number is divisible by 8, then we could say that the number is divisible by 8. So in this case of numbers, it's almost similar to doing the normal division. But if we're getting a very long number like 8, 5, 6, 7, 4, 3, 4, 8, 3, 2, we have to just check the divisibility in these 3 digits in order to determine whether this number is divisible by 8. Now, divisibility by 9, if the sum of digits is divisible by 9. We have the same thing going on with 3. That is, if I'm taking a number like 728, what is the sum of the digits? 7 plus 2 plus 8. That is 17. Is it divisible by 9? It's not divisible by 9. So it just explains that it's not divisible by 9. So moving on. Now the divisibility by 10. Everybody know the divisibility of 10. So any number which is divided by 10, divisible by 10, is actually would have a 0 at the end. That is a number saying 2080, it have 0 in the end, so it's divisible by 10. 7980, again 0 in the end, so it's divisible by 10. Now divisibility by 11. So if we have a number 4321, these are the numbers in the odd places and these are the number in the even places. So if we are adding these two numbers in the odd places, that is 3 plus 1, and in the even places it's 4 plus 2, this is 6 and this is 4. And if this is a multiple of 11, then we could say that the number is divisible by 11. So this is the test of divisibility of 11. Now let's move on to 12. 12 is the same situation as 8. Sorry, it's the same situation of 6. Because 6 we said that the factors are 3 and 2. So if they're both divisible by 3 and 2, it is divisible in 6. Now in 12, the factors are 3 and 4. So if a number is both divisible in 3 and is divisible in 4, we can say that that number is divisible in 12. And finally, we come to the divisibility by 25. So the divisibility of 25 can be done in such a way that if there's a digit called 775, we check the last two digits. So 75 is divisible by 25. So basically this is divisible by 25. So in case of 25, we check the last two digits, and if it's divisible by 25, we could say that the number is divisible by 25. So these are the tests for divisibility we have as of now. So now we get into the part where we test whether a number is prime. We've talked about prime numbers. So prime numbers are the numbers which have factors like 2, 3, 5, 7, 11, 13. These are all prime numbers. What is the speciality of these numbers? It just have two factors and one of them is 1 and the second one is the number itself. So how do we test whether a number is prime or not? Okay, the first basic method is if I'm taking a number 18 and I'm prime factorizing it. So first, the basic thing we could do is 2. 2 9s are 18. And again we could do 3. So 3 3s are 9, 0. Again we could do 3. Gives me 1. So 18 could be written as 2 into 3 into 3 into 1. So we have 1, 2 and 3 factors here. So which could say that it's not a prime. At the same time, if I'm taking 19 and prime factorizing it, the only factor which I'll get is 19 and 1. So 1 and 19. This is a prime number. So this is a method to find whether a number is prime or not. So next we are moving on to the decimal number system. The decimal number system is a number system which contains around 10 digits, which is 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Again we go to 10, it's basically 1 and 0, which are the two digits. So the decimal number system is pretty much easy. If you're representing a number in 10.08, what is the place value of this number? It's 10 raised to 0, ones place. It's 10 raised to 1, tens place. This is 10 raised to minus 1. 10 raised to minus 1 is 0.1. And here it's 10 raised to minus 2. This is 0.01. So these are the place values of the number in a decimal number system. It's all about decimal number system. And now we have a very interesting way to represent a very large number into a standard form. Let's say we have a thing. We just say that the light travels very fastly. The light travels in the speed of 3, 8, 1, 2, 3, 4, 5, 6, 7, 8 meters per second. But is it practical to write this many zeros in a paper? Or it's very difficult to read when we have a value like 36000000. When we have a lot of zeros going on, it's very difficult to keep up with it. So we use a standard form to represent these kind of numbers. This number can be written as 3.8 into 10 raised to 8. We have 8 zeros here, 6, 7, 8. So, okay, this number could be written as 3.8 into 10 raised to 9 because we actually skipped here. But the speed of light is actually, the zero cutoff. So, if we're writing the speed of light 3.8 into 10 raised to 8, it goes like 3, 8, 1, 2, 3, 4, 5, 6, 7 zeros because we're skipping 8 decimal places here. So 1, 2, 3, 4, 5, 6, 7, 8. Now you get it. So the standard form is represented as A into 10 raised to K, where A should be between 1 and 10. What does this mean? So K could be any other integer. So K could be 1, 2, 3, minus 1, minus 2, anything. So if we have a number say 0.0000567, how can we write this number? We need an integer which is A, which is in between 1 and 10. So we move this decimal point how many times? 1, 2, 3, 4, 5. So we move it 5 times. 5.67 into 10 raised to, how many times did we move? We moved it 5 times and we moved it to the right. So we'll use it here as minus 5. If we are going to the right, it's always negative, and if we are going to the left, the decimal points, it's always positive. As in, if we have a number called 878900000, we could represent this as 8.789 into 10 raised to, how many zeros? 1, 2, 3, 4, 5, 6, 7, 8. 10 raised to 8. This is how we represent extremely large numbers in a standard form. So this is all about number systems in our topic.